Alright, so in this short video I'm going to be going over the three basic examples from class, and one will be absolute value with equals, one will be absolute value with less than, and one will be absolute value with greater than. So let's take a look at the first one, and you can just copy these down at the bottom of your notes and use them for class. We need to set up two equations. X minus 4 equals 2 and x minus 4 equals negative 2. And so we solve these. We can add 4 to that side, and so one of our answers is 6. We add 4 to this side, add 4 to that side. Our other answer is going to be 2. For graphing with equations, it's not as important, but I will. So we have two values on here. We'll have 2, we'll have 6, and we're going to fill this in, and those show our two solutions for x, and you can check that really easily. 2 minus 4 has an absolute value of 2, 6 minus 4 has an absolute value of 2. Alright, the second example is going to involve the absolute value of an expression being less than a number. So you have the different forms to help you set up these on your notes. And so there's two things that we're going to set up. The first is that we want 2x minus 8 to be both less than 4 and less than negative 4. So we want two different endpoints because the distance has to be within 4 of 0. So negative 4 and 4 on the outside, 2x minus 8 on the inside. So we're going to solve this by adding 8 to each of those terms. So now we have 4 is less than 2x is less than 12. Of course, the 8's opposite 8 and 8 cancel in the middle. And then we're going to divide everything by 2 so that we'll have x in the middle. And so we have 2 as an endpoint here, we have 6 as an endpoint there. So my answer is a double inequality because I have a less than sign. And so if I go ahead and graph this, I'm going to have 2 and 6. I'm going to have open circles, and I'm shading everything in between. So my final answer is both the double inequality here, 2 is less than x is less than 6, and represented by the graph, which means anything inside the shading would check here and have an absolute value less than 4. The third kind of example is similar to the last one, except we're going to work with greater than. Alright, so we're looking at what value of x when I multiply by 4 and add 1, is it greater than 7 away from 0? So I'm going to set up two different inequalities. 4x plus 1 has to be less than negative 7, or 4x plus 1 has to be greater than 7. Because I want to go in opposite direction, so it's got to be less than negative 7 and greater than 7. Both of those, negative 7, 7 are of course 7 away from 0. So when I solve these, I'm going to have, for this first one, 4x is less than negative 8. Divide by 4. And x is less than negative 2. That's one set of numbers. I solve this one over here. 7 minus 1 is 6. Divide by 4. And x is going to be everything greater than 6 over 4, which is also the same as 1.5. So when I go ahead and graph this, I have my number line. Always go smallest to largest, so I have negative 2 here. I have 1.5 here. And I have open circles, and I'm shading this direction, greater than 1.5, and less than -2. So the values that are in the shading here, when I multiply them by 4 and then I add 1, their absolute value will be greater than 7.